My name is Marcus Stack, and I'm a third-year mechanical co-op student at the University of Alberta. I'm working with the EcoCar team, and on the team some of my roles include VP sponsorship, but I'm also very much involved with the mechanical team. So from the mechanical side of things, one of my most recent projects that I'm very proud of was working on the aeroshell. So it was very much an interdisciplinary project. We had an industrial design student provide a design for us to work with from the start, and I took that information and then I tried to create an aeroshell from that we could use for our car. And it took many months of work to take his design and try to create something that would work with the rest of our car, but we're at a point where we're now manufacturing the aeroshell, so it's an incredibly exciting process, and it's great to see that we've come so far. So here you can see we have the solid model of the aeroshell. Unfortunately, some of the limitations are safety-wise when it comes to the different size and height parameters, and it was a struggle to create something that looked beautiful but was also very functional and aerodynamic. One thing about having a hydrogen fuel cell car is that you need air intakes. So you can see right here we have air intakes that are designed to get the air from the outside environment into the fuel cell. So that was another area that we had to work around. Of course, we were always trying to design with aerodynamics in mind while trying to maintain something that was attractive but functional. Here you can see, once again, these are the air intakes, and those are necessary for our car to be able to work. But one thing you'll also notice is that the remainder of the profile is very smooth, and that was another element that was incredibly important, because without that we lose a lot of fuel efficiency when it comes to our car. And as an EcoCar project, that's one of our highest priorities, is having the best fuel economy as possible. Of course, this project was heavily based in SolidWorks. There were a lot of different elements of SolidWorks that I needed to learn. Working with surfaces was one area that was definitely a huge learning curve, but also starting to work with computational fluid dynamics and understanding how we could use that to improve our model. That was something that we definitely needed to work with as well. And then, of course, working together with other teams, understanding how you can create something from an industrial design idea and then making it into a SolidWorks creation, and then going back and then turning that into a real product. So that was an incredible process. For this project, the fundamental tool was, of course, SolidWorks, but then it also took an incredible team of volunteers, about 24 hours, to go and take foam blocks and cut them down by hand so that we could create section profiles of the aeroshell that were then machined at a machine shop down in Calgary. So it was an incredible amount of work from a whole bunch of people to make this possible.